Hey guys, this is part 2 of our last episode about the planets in our solar system. The first planet that I'm going to be talking about in this part of the episode is Jupiter. Jupiter is our first non-terrestrial planet. It's the 5th planet from the Sun and the largest one in our solar system. It can fit about 1,300 Earths in it, and the Sun can fit about 1,000 Jupiters. This not only shows the immense scale of Jupiter, but that of our Sun as well. Jupiter is about 86,880 miles in diameter, much larger than any of the previous planets. You might expect Jupiter to have longer days than Earth, but it actually has much shorter days, yet a longer year. One of Jupiter's days are about 9.84 hours, while one of its years are equal to about 12 Earth years. Jupiter spins much faster on its axis than the Earth does, giving it a faster day, yet it has a larger orbit extending its year. We have to remember that time is all relative in space, so it can be hard to wrap your head around these incredible differences in how we view time passing all around us. Jupiter is a gas giant with a force of gravity 2.5 times stronger than the Earth. If you were standing on Jupiter, you would just fall through until you reach the inner layers, which are thicker, meaning you'd essentially be able to swim through the core. Something widely known about Jupiter is its giant red spot. On any picture of Jupiter, you can see a red spot facing the camera. That spot is actually an anticyclonic storm, the largest in our solar system, and has been mostly observed. The storm itself is about 10,060 miles across. The difference between an anticyclonic and a cyclonic storm is that a cyclonic one is low pressure, while an anticyclonic one is extremely high pressure. Jupiter has 67 moons, and it has a ring that is thin and hard to see, unlike Saturn's, and Jupiter is extremely cold around the outer layers and extremely hot close to the inside. Now for Saturn. Saturn is also a gas giant and is famous for having very noticeable rings. Its rings are made out of ice, dust, and rock, ranging from pieces as small as a grain of sand to ones as big as buildings. Saturn's rings look stable enough to land and walk on, but they're actually not solid at all. While Saturn has over 150 moon-like objects revolving around it, it has 62 confirmed moons that keep all the ring components in place while they orbit Saturn. The planet is the second largest in the solar system, with a diameter of about 36,180 miles, and is extremely cold, with an average temperature of negative 178 degrees Celsius or negative 352.4 degrees Fahrenheit. Due to the increased pressure in the planet, the closer you travel to the core, the more hydrogen changes state. Hydrogen changes from gas to liquid below the determined surface and from liquid to a metallic hydrogen close to the core. 1 day in Saturn is 10 hours and 42 minutes, and 1 year in Saturn, or 1 revolution around the Sun, is about 29 years long. Determining the length of a day in Saturn was extremely challenging for the scientists. Rather than just waiting for a distinguishing feature of the planet to come back into view, its non-solid surface led them to use Saturn's magnetic field to determine the length of a day. The second to last planet from the Sun is Uranus. Uranus is another gas planet and is characterized by its bluish-green color from the methane in its atmosphere. 1 day on the planet is a little over 17 hours, and 1 year is 84 Earth years. It has only 27 known moons and 2 very darkly colored rings. Uranus hits the coldest temperature of any planet, with its coldest temperature being negative 224 degrees Celsius, which is about negative 435 degrees Fahrenheit. It's also known as the ice giant, along with Neptune, because its rocky, icy core is larger proportionally to the immense amount of gas that is visible from the outside. Finally, the 8th planet from the Sun is Neptune. Neptune's orbital period is about 165 years, and one day is a little over 16 hours. It's also an ice and gas giant, very similar in composition to Uranus. It has 14 known moons and 3 main rings, however they are very thin and very dark. Uranus is colder than Neptune because the methane traps the heat entering Neptune's atmosphere and keeps it there. Since hydrogen and helium have no greenhouse properties when isolated, the heat trapped in Neptune's atmosphere due to the methane keeps it from surpassing Uranus in terms of cold temperature. If you want to learn more cool facts about the planets in our atmosphere that are so similar yet so different at the same time, I linked a couple sources that I used when I was researching, as well as some facts that I didn't say in the description. The planets from part 1 have their own links, while the planets from part 2 have separate links. Thanks for listening, and I hope you found it as interesting as I did making it.